Welcome back. Now we are going to see the question answers for this chapter. Again, I am not going to spoon feed you. We are going to discuss all the questions, the portion or the answers what we have discussed completely thoroughly with diagram etc. We are not going to solve it here again because this is not mathematics class. Okay, so let us see few questions that are appeared in the board exams and let us solve them. What is mean by refraction of light? It was for 1 mark in October 12, 13, March 14, March 16. That means almost every year this question is asked. Okay, so what is the mean by refraction of light? The phenomena of changing direction of propagation of light when it passes obliquely from one medium to another medium. This is called refraction of light. Mind well, this is the definition and you have to write word by word from your comma by comma from your textbook. Why is there a change in direction of propagation of light when it passes obliquely from one transparent medium to another? The answer to this question is very simple, because the velocity of light in different medium is different, and that is why the refraction takes place. Then we have seen the glass activity, glass slab, and how to draw that diagram. We have drawn that diagram perfectly: incident ray, normal, and then refracted ray, and again the refraction happens when it comes out of the glass ray. That we have already seen in detail. In case of refraction of light through a glass slab, the emergent ray is parallel to the incident ray, but it shifted sideways. Why does this happen? Very simple. First, the light enters the glass slab, that is from rare medium to denser medium, so the light refracts and shifted towards the normal. Then it comes out of glass slab, that is from denser to rare medium, so it goes away from the normal. So ultimately, whenever the light comes out, it is parallel to the incident ray but shifted towards right side. Define angle of incidence and angle of refraction. What is incidence angle? The angle made by incidence ray with the normal at the point of incidence, means the angle made by incident ray with the normal at the point of incidence is called as angle of incidence, and when it deviates, refracts, the angle, what is the angle of refraction? The angle made by refracted ray with the normal at the point of incidence is called as angle of refraction. Okay, very simple. State the laws of refraction of light. Appeared for 2 marks in October 12, 13, 14 and March 14. That means laws of refraction, again 2 marks, nearby every year. Okay, very important. There are only 2 laws. The first law is the incidence ray and the refracted ray are on the opposite side of the normal at the point of incidence. This is the first. And second is sin I upon sin r is equal to neta. That is the refractive index. Okay. How is refraction of light related to refractive index? This is for 2 marks, appeared in March 16 examination. Important question. Very simple. Whenever the light ray travels from rarer or lighter medium to denser medium, the refracted ray bends towards the normal, and whenever from denser to lighter, it goes away from the normal. This is how the refraction is related with the rays. And if it is the angle of incidence is 0, then the deviation is also 0. Another point you have to mention there is, if the refractive index of the medium is more, then the refractive ray will bend towards normal. Like in case of glass, it bends towards normal. Okay, and in case of lighter medium, it goes away from the normal. Next, again, define the refractive index of the second medium with respect to the first medium, or what is meant by refractive index. This question appeared for 1 mark in October 13 exam. Very simple. You have to write a definition of refractive index. Either it is refractive index of the second medium with respect to first medium, or first medium with respect to second medium, whatever it is the sin I upon sin R, or the velocity through second medium upon velocity through first medium. This is the refractive index of second medium with respect to first medium. State the formula for refractive index of the second medium with respect to the first medium. It is V2 upon V1. You have to write it properly, that V1 is the velocity of light in first medium, V2 is velocity of light in second medium. So the refractive index neta 1 neta 2 is equal to V1 upon V2. Next, define absolute refractive index. The refractive index of any medium with respect to air or vacuum is called as absolute refractive index. Obtain the relation between the refractive index of second medium with respect to the first medium and the refractive index of first medium with respect to the second medium. Very simple. I have explained you clearly, that is 1 neta 2 is equal to V1 upon V2 and 2 neta 1 is equal to V2 upon V1. This is what they have asked. Explain the term optically rarer medium and optically denser medium with example. Now, dense and rare and optically dense and optically rare are different terms. Okay, let us see how. Whenever the medium is rare, its refractive index is less. Whenever the medium is dense, its refractive index is more. Now, what is the difference between optically rare and general rare? I'll tell you that the density of kerosene is less than that of density of water, but the refractive index of kerosene is more than that of the refractive index of water. That means these two are different terms. Optically dense and general dense is different. Okay, and so is in the case of water and kerosene. So we can say that kerosene is optically dense and water is optically rare. But density wise, kerosene has got less density than that of water. It floats on the water. Next question. A ray of light is incident obliquely at the boundary separating two media. What is its behavior if refractive index of second medium is greater? Now all these questions are on the optically rare and optically dense. If the first medium is rare than the second medium, then how the refracted ray will bend towards normal or it will go away? What will happen if the first medium is optically denser than the second medium? On this phenomena, majority of the questions will depend, and we have already seen this number of times, so no need to answer this question by me. In this case, just remember one thing: whenever you are explaining these answers from the denser medium and rare medium and refraction of the light rays, you have to draw ray diagram. You have to draw diagram. Rectangle, show the normal, incident ray, refraction, then angles you have to show. You have to name the label diagram. Okay, label diagram is must. You should not just show the incident ray and refracted ray like that. Okay. Next, what happens when the ray of light is incident normal to the interface between two media? Simple. It is coincides with normal. So angle of incidence is 0, but natural. The angle of deviation is also 0. That is, the angle of refraction is 0. It will not deviate at all. It will straight pass through the second medium. Okay. Draw the neat label diagram to show the path ray of light in air and glass when the ray incident obliquely. This is the first diagram what we have seen, the label diagram of the light ray passing through the glass slab. This is the same diagram. It appeared in October 14 exam for 2 marks. Observe the given figure and name the following rays. This is for 3 marks in March 12 exam. The figure they have given is, what is ray AB? AB is incident ray. Ray BC BC is refracted ray, and ray CD is emergent ray. This is refracted again, but this will be called as incident, refracted, emergent. Okay, just remember this nomenclature. Next, give two examples of effect of atmospheric refraction on a small scale in local environment. You can give the example of mirage, and at the time of Holi, how you see the shattering, that is the shaking images, that you can explain. This was in October 13 exam for 2 marks. Now again, they say that a plain mirror is kept at the bottom of the water is there, or some liquid is there, then one light source is there, point light source is there, and they say draw the ray diagram, proper ray diagram. So how we will draw the ray diagram? This is the normal. First of all, the ray will come here, then it will get from here, then it will get, and then again it will go out. Now this ray diagram you have to draw. You have to name it. This is the reflected, this is the refracted ray, this is the reflected, because this is mirror, this is reflected ray, this is emergent ray, and this is incident ray. Okay, you can show angle, of course. You can draw normal at this point, normal at this point. You can show these angles also, doesn't matter. You can show this angle, doesn't matter, but the diagram must be a proper label diagram. When you can see a mirage, I have already explained you this thing. Whenever the temperature of the surface of the ground is increasing, what happens? A layer of hot air produces, hot air goes up, hot air is optically rarer medium than cold air, hot air goes up, and so the layers of the different temperature of air forms there. The medium changes, so the refraction of light takes place, and this refraction of light is continuously changing. So what will happen? The rays from the top of the object, if this is the surface and if this is a tree or some person is standing there, what will happen? The refraction of the rays from the top and bottom get crossed while reaching the observer, and due to this continuous temperature difference, what will happen? The image is appear to be formed at the bottom. Okay, so it gives you illusion that the water is there, and again, since the refractive index of the air is continuously changing, what happens? This image is shaky, so you feel that some water is there and it is reflection is shaking. So that is called as the mirage. Explain twinkling star. Also explain why planets does not twinkle. We have already seen this in detail. Better if you can draw the figure of this also. Explain advanced sunrise and delayed sunset. We also seen this while we were explaining about the position of the star. We know that due to the refraction, because whenever the sunlight comes from the outer space on the earth, what happens? It travels from the gradually increasing density medium, that the density of the medium is gradually increasing. Okay, at a height the atmosphere is rare, optically rare, and at the bottom, at the sea level, it is dense. So what happens? Generally we see the object, or generally object is appeared just above the actual object is. So at the time of sunrise, what happens? Whenever the sun rays comes, I am standing on the horizon. Since the image is always appeared above it, so before actual sunrise, I will see 2 minutes before the actual sunrise. And at the time of sunset, what will happen? Even after sun is set, it is actually gone below the horizon, but my apparent image is just above, so I will see the sunrise or the sun even though it has gone below horizon. That is what is advanced sunrise and delayed sunset. Advanced sunrise is by 2 minutes and delayed sunset is by 4 minutes. Next question is, what do you mean by dispersion of light? What is the spectrum of light? Name the different colors of light in the proper sequence in a spectrum of light. Or, what do you mean by dispersion? Name the different colors of light in the proper sequence of spectrum. Now this was in October 14 exam for 3 marks. I already explained you what is the dispersion of light. The phenomenon of splitting the light into its component colors. The phenomenon of splitting the lights into its component colors is called as dispersion of light, and that color band is called as spectrum. Now we know that the red deviates or refracts minimum and violet maximum, so we see the color band from red to violet, and the colors of rainbow everybody knows. So this is the color spectrum: red, orange, yellow, green, blue, indigo, violet. What is a prism? A prism is a transparent medium bound by two plane surfaces inclined at an angle. Next, draw the neat label diagram to show dispersion of white light or sunlight by a glass prism. It was for 2 marks in July 15 exam. We have already seen what is the dispersion and we have seen the proper label diagram for this. Let us go ahead. Describe in brief the experiment to demonstrate dispersion of sunlight, white light by prism. Very simple. We have to take one prism, we have to get the sunlight or point source, and we have to, on the other side of the prism, we have to put the screen, and we should take the color band on the screen. So this is the simple example. Next, how does the dispersion of white light takes place when it passes through a glass prism? Very simple. Again the same question. You have to show the same diagram and show the dispersion of light. Next question. What is a spectrum? Why do we get a spectrum of 7 colors when the white light is dispersed by a prism? It was in the March 15 and March 16 exam, 2 years consecutive for 3 marks. Now why do we get the spectrum? Because we know that the sunlight or white light is a combination or is a mixture of different colors. It's a mixture of different colors, and when it passes through prism, the different color deviates at different angle. The refraction of different color light is different. The red color deviates minimum and the violet color, refraction of violet color is maximum, and so we get all colors separately. Since it is a mixture of 7 colors, we get the band of 7 colors. That is what we call as spectrum. Explain how the formation of rainbow occurs. This was for 3 marks in March 13 and July 15 exam, likely to come in this year's exam. Okay, very simple. We have already seen in detail what is the reason behind a rainbow, because the droplet behaves like a prism. So first the refraction and dispersion takes place, a spectrum is formed, and then that spectrum is inside the droplet, is reflected. When it comes out, it refracted again, and as a combined effect of the millions of these tiny water droplets, we see the rainbow. So this is very simple. We have already seen in detail. What is scattering of light? Again, whenever the light incident on a tiny particle, it gets reflected in different directions, uneven different directions, that is called as the scattering of light. Give an example of scattering of light. Of course, we have at least 2 examples. The first is the sky appears blue in the daylight, and then you can give the example of sunrise and sunset, why those appear red, orange and yellow shade at the time of sunset and sunrise. Okay. Then again we have seen the image of the scattering of light. We have taken one beaker in which water and some colloidal solution is there. One point light comes from there. One cardboard of one hole and one convex lens, and a screen was there. What happens? First of all, when the light passes through colloidal solution, tiny particles are there which scattered the blue light. Blue light is totally scattered. So only red light, which deviates minimum and travels longer distance, will pass through the cardboard, and the image is formed of crimson red color on the screen. Whereas if you see the beaker, you will see the bluish shade, because the maximum scattering of blue light is there. Now on this chapter, again and again same questions are being asked. Reflection, refraction, dispersion, scattering of light. Only 4 phenomena are there of light, and on this, based on these 4 phenomena, they are just twisting the questions. Sometimes if the longer questions are there, those are for 3 marks, 4 marks, otherwise 2 marks, 1 mark. Definitions are there, because this chapter itself is very small chapter. So let us see some give reasons. Scientific reasons are there for 2 marks. 1. Star twinkles at night. We know that. Why planet do not twinkle? Because the distance is lesser than that of the stars. Star is the source of point light, whereas the planet is the collection of the point light sources. So even if some point light sources are brighter, others are dull, some are dull, then others are brighter. So ultimately the overall effect is no twinkling. The sunrise is advanced while sunset is delayed. Again, the same thing we have seen in the long questions. Then, the sky appears dark instead of blue to a person located in space. Already we have seen this, because there is no atmosphere, so the scattering of light is not there, and so it appears dark. Okay, this was appeared in March 12 exam. The sun appears reddish early in the morning. Again, very simple answer to this. At the time of sunrise and sunset, the distance from the observer to horizon is greater, so the light rays or sunlight has to travel longer distance. Then the density of the atmosphere is high than when the sun is at top. At the sea level, the density of the atmosphere is high, and so what happens? All the blue violet lights are scattered away, and since the light ray has to travel longer distance, only the red, orange and somewhat yellow lights, which are not deviated or not scattered much and can travel to the longer distance, reach to observer, and we feel that the sky is red, orange or yellow shade. Next question. To an observer on the earth, the sky appears blue. Simple thing. The atmosphere is made up of the tiny particle like air molecules, dust, then smog, fog. Very tiny particles are there, and this tiny particle scattered the blue light the most. Okay, and due to this scattering of the blue light, we feel that the sky is blue. Danger signals are red in color. It appeared in March 15 exam. Again, we know that same answer you have to give. The atmosphere is a homogeneous mixture of the tiny particles. Now the deviation or the scattering of the light depends on the wavelength of the light, that is the color of the light, and the size of the particle. We know that the blue color scatters more. There are tiny particles in atmosphere, and the blue color scatters more. It deviates maximum, whereas the red color deviates minimum and can travel the longer distance. So that is why the danger signals are always red in color. Is it possible to enjoy rainbow at fountain in any season? Of course, it is possible to enjoy rainbow in any season, because what we need to form a rainbow? Tiny particles or the tiny water droplets, the sprinkle of the tiny water droplets, and sun rays coming through it. So if that is there, you can enjoy the rainbow in any season. You must have observed that all the question and answers are depend or basically based on only 4 factors: reflection, refraction, dispersion and scattering of light. So again and again, by turning their language, they are asking the same question. But the main thing is, you have to, whenever such questions are there, always try to draw a diagram. Stars are twinkling, draw diagram, because it is apparently will be on the top of it. When sunrise, sunset, draw diagram. Whenever you are drawing some diagrams, the examiner is assured that you know the answer. Because if you don't know the answer, you will not able to draw the diagram. And sometimes it happens that you remember the diagram, but you don't remember the exact wording of the answer. In that case, just explain the diagram. That's all. Whenever you are explaining the diagram, you are explaining the answer. So in science, always try to draw some kind of diagram, ray diagram or whatever. Try to draw some diagram in case of science answers. Okay? Because if you see the pattern of your exam, you have a lot of time to solve your paper. Okay? Even the numericals are extremely simple. In case of this chapter, we have seen only one formula is there. Sin I upon sin r is equal to neta is equal to V1 upon V2. That's all. Nothing is different. You have to just remember that whether they are dealing with the absolute refractive index or not. So while revising your chapter, you can easily revise for the fill in the blanks, answer in one line and so on. By concept map, what I have shown you, you can easily revise this chapter in 5 or 10 minutes. So that's all about Wonders of Light part 2, chapter number 7. Here we finish it. Thank you very much.